Right, good morning. Good morning, everyone. Let's start our session. Let me share my screen. So we were discussing about Kubernetes. I think we were discussing about the services like service objects, right? We were discussing about service objects. Service object means what? So it is also one of the object in the Kubernetes. We have started discussion with the pod. What is the smallest object that we can create in the Kubernetes? The smallest object in the Kubernetes is pod. The very smallest object that we can create in Kubernetes is pod. After pod, we have seen how to create a replication controller. After replication controller, we have seen how to create replica set. Pod, replication controller, replica set, deployment object also we have seen. After deployment object, we discussed about some service objects. Service objects are three types actually. See in the YAML file, if you do not mention the type of the service, I already told you in the YAML file, if you do not mention the type of the service, what happens? It will take the default service as cluster IP. What do you mean by cluster IP? The default type is cluster IP. If it is taking as cluster IP, this means the pods will communicate each other inside the network, but pods will not communicate with the external network. Pods cannot communicate each other with the external network. I already told you the difference between the service objects. Let me explain you once again very clearly. What is the meaning of this service objects and all? Consider we have a cluster. Inside the cluster, we are going to take few nodes. Okay, this is node 1 and this is node 2. And you can also see this is our node 3. Node 1, node 2 and node 3. Okay. Node 1, node 2. This is node 3. Okay. So we have three nodes, node 1, node 2 and node 3. And here what I told you is we can create pods, right? We can create pod inside the nodes. So we can create pods inside the nodes. I can create, this is pod 1 and I can create pod 2 inside the node 2. I can also create pod 3 inside node 3. Like that we can create pods inside the nodes also. So we know how to create nodes and we know how to create pods inside the nodes. That this is called cluster. This is the entire cluster. And you must understand that each and every node will have an IP address. So this node will be having an IP address. This second node will also have IP address. Each and every node here will have an IP address. Node 3 will also have IP address. Each and every node here will have an IP address. See, node 1 is having IP address, node 2 is having IP address, node 3 is also having IP address. How many pods are there? Pod 1, pod 2, pod 3. Inside each and every node, we have created one pod. So now what happens? Suppose if pod 1 is running, consider pod 1 is running on the node 1. Okay, I'm talking about cluster IP. Okay, there are three types of service objects. What are the service objects we're having? Try to understand what are the three types of service objects. Service objects are of three types. First one is cluster IP. Service objects are of three types. First one is cluster IP. Second one is what? So first let us discuss about cluster IP. If it is a cluster IP, what happens? Each and every pod is having some IP address. Each and every node is having some IP address, right? So if the pod is running in node 1, we can able to access that pod only by using the node 1 IP address. That's it. If the service object is of cluster IP, the service object is type cluster IP, then what happens? If the pod 1 is running in node 1, we can access pod 1 by using the IP address of node 1. That's it. If pod 2 is running in node 2, we can able to access pod 2 with the help of node 2 IP address. If pod 3 is running in node 3, we can able to access pod 3 by using node 3 IP address. That's it. So external is not possible. External communication is not possible. That means I cannot access pod 1 by using node 2 IP address. That is one thing. I cannot access pod 2 by using node 1 IP address. This is not possible. in cluster IP. This is possible in a type called, this is possible with the type called, this is possible with the type called. Second, what is the second type we have discussed about? Node port. This is possible with the help of node port. If the cluster is of type node port, what happens? External communication is also possible. What do you mean by external communication and internal communication? I told you, we just now we have understood what is internal communication. If you want to know what is external communication, try to understand. If the pod 1 is running, consider if the pod 1 is running in the node 1, even the pod 1 can also be accessed by using node 2 IP address. That's okay. Suppose if pod 2 is running in node 2, this pod 2 can also be accessed by using node 1 IP address. You understood, right? So that means what? Node port in the sense, pods will communicate with each other. Pods will communicate with each other. Pods will communicate with each other by using external network. The pod 1 can be accessed by using node 1 IP address, node 2 IP address, node 3 IP address. You can access pod 1 by using either node 1, node 2, or node 3. Okay. So even if the pod is running in one machine, we can access that pod by using the other machine's IP address. We can access that pod by using other machine's IP address. This is called node port. Then what is the other one? Load balancer. What is the load balancer? Third type is there. We have another type of service object that is called load balancer. What is the use of this load balancer? See, load balancer means, let me show you some AML file for this load balancer. And sir, this is the AML file. If this is the AML file and the type is specified as load balancer, it's normal. It looks like normal AML file only. You already know, right? API version, kind, metadata, specification. Very simple AML file you can take. But if the type is specified under specification section, if the type is specified as load balancer, what happens? The main purpose of load balancer is like, you can find the IP address created for your service. You can find the IP address created for your service by getting the service information. So the main advantage of load balancer is, show you, it is similar to the node port only. Load balancer is similar to the node port only. Whatever the advantages we have seen in the node port, every advantage is similar to the node port only. But it is also used for external connectivity of the pod and also network load balancing. That means commonly it assigns a public IP. It assigns a public IP for all the nodes combined together. When I use a type load balancer, it assigns a public IP for all the nodes combined together. It assigns one public IP for all the nodes combined together. By using that public IP, we can access the pods running inside the network. So this is called load balancing. For what purpose we are using load? What is the meaning of load balancer? What is the meaning of load balancer? I already told you. See, load balancer means what? Suppose the same pod, the Flipkart pod is running. You will consider that this is the same pod. This is not a different pod and all. Flipkart pod 1 is running in node 1. Similarly, the same Flipkart application, same pod is running in, but we are calling it as Flipkart pod 2. Flipkart pod 1 is running in node 1. Flipkart pod 2 is running in node 2. Similarly, Flipkart pod 3 is running in node 3. What is the use of load balancer now here? If a same IP address is assigned, by using that same IP address, we can access the application. But internally, the load will be balanced. We will be, okay, public IP will be assigned. Public IP will be assigned for the entire, for all the nodes combined together. A public IP is assigned. So public will be accessed by using the public IP. So this public IP will divert the request to the nodes internally. This public IP will divert the request to the nodes internally. If some request comes, it will divert to the node 1. Some another request comes, it diverts to the node 2. Some other request comes, it diverts to the node 3. So in this way, it diverts the request to the nodes. So that is the meaning of load balancer. So whatever the node port you have seen, the same concept of node port will be implemented in the load balancer. But along with that, a public IP will be assigned. So let me show you. We have already created a cluster. A cluster is
Public
running.
IP in the sense like
Public
same IP will to all the
Yes,
ports.
actually each and every machine, each and every this is a cluster, right? So in this cluster, consider we have two nodes. Each and every node will have one public IP, right? Individual public IP, right? Each and every one will have individual public IP. So we can also see that public IP also. I'll show you now. Okay, let's see this example. You'll understand. Okay, we have some service objects here, service one like that. Let me create one more service object. See, I'm going to save the service object. I'm going to save the service object as I'm copying this. Okay, let me take this example. So name of the service is example. You see here the service kind. The kind is service object. For all the service object, the kind will be like service only. What is the type here? The type might be cluster IP, node port, otherwise load balancer. You understood, right? What is cluster IP? If we do not specify defaultly what it will take, if we do not specify the type, or if it is not a service object also. If you do not specify the kind as service also, default which service it will take? Cluster IP. By default, it will take cluster IP. What is the advantage we are having if it takes the cluster IP? Inside communication, that's it. If pod is running in node 1, we can access that pod by using only node 1 public IP, that's it. So then later, we have an advantage of node port, another service object called node port. If the type is specified as node port, what happens? Even if the pod is running in node 1, we can able to access pod 1 by using node 2 IP address also. So you can access any node IP address for accessing the pod. That is called node port. Then what is the cluster? What is this one last one? Load balancer. So I'm going to copy this same YAML file as it is. So give the service name as service2.yaml, vi space service2.yaml. I'm going to paste it. Understood, right? We have specified the type as load balancer. We understood the type as load balancer. So what happens if the type is load balancer? We're just taking an example, okay? Escape, shift : WQ. So how to run? You all know that. How to run this file and all? You all know that. We have a command called what? What is the command we use for creating? Can you remember? Do you remember what is the command we use? kubectl create -f service2.yaml. Okay, service2.yaml. kubectl create -f service2.yaml. So if you give that command, then it will see that service is created, service object is created. Okay, service object is created. Then we can also use a command here. You see, we can also use a command to understand what is this load balancer and all. We can use a command called kubectl describe. See here, kubectl describe command is there. We can use this particular command to see the list of to see the entire details about the service object, or otherwise any. You can give this command. Suppose if one service object is running, you can give a command like kubectl describe and the service object name, so that it will provide you the entire details about the service. I'm going to give the command kubectl describe. Okay, kubectl describe and the service name. Kubectl describe. What is the service name? Service2. ML. If I give this one, you see it will provide some. What happened? The server does not have a resource. Sorry, what is the service name? Example service, right? kubectl describe. kubectl describe services example service. If I give this command, you see. Anyhow, each and every compute, each and every node will have some IP address. That is fine. But one load balancer ingress IP address will be assigned. So for by using this IP address, we will access the pod. Understood, right? One IP address is assigned. One common IP address is assigned. This is the IP address that is assigned for this. This is called load balancer ingress. Ingress means what? What is this load balancer ingress? So if you use the service object as load balancer, this load balancer ingress will be created. So by using this IP, we will be accessing the pods. So usually what happens, each and every node will have one IP address, right? So first node will be having one IP address, second node will be having one IP address, third node will be having another IP address. That is fine. But what happens, it is assigning a common IP address for all the machines combined together. Why it is assigning common IP address? What is the necessity? Why? Because while sharing the IP address to the public, while sharing the URL to the public. So if you are going to design a website called Facebook, so we will share the website name as www.facebook.com. Okay, we will share the domain name as www.facebook.com to the public. So all the public will be accessing the website by using www.facebook.com, right? So for that domain, we will integrate the IP address. For that domain, we can integrate only one IP address. We cannot integrate multiple IP addresses for the domain, right? We can integrate one domain name for a single IP address. So for that, we need a common IP address. We need one single IP address for accessing the pod. Wherever the pod is running, doesn't matter whether the pod is running in node 1, whether the pod is running in node 2, whether the pod is running in node 3, doesn't matter for us. We need some common IP address that needs to be shared to the public. So public will access by using a common IP address. So from this, the request will goes to the individual nodes. So it manages, this ingress will manage the load. It is nothing but a load balancer. Ingress is nothing but a load balancer. Simply, we can say that it is like a load balancer. So first, what happens? First, whatever the request comes from the public, that request goes to the common IP address. From the common IP address called ingress, it will go to that ingress will divert the request to the Flipkart one. If Flipkart 2 pod is busy, it will divert the request to pod 3. It will balance the load. Everything will be balanced by the load balancer. So that is called load balancer ingress. So once you define the service object as load balancer, one common IP address will be assigned for all the machines together. So we will share that common IP address to the public. Public will be able to access by using that common IP address. So the request will goes to that common IP address. From there, the request will be diverted to the individual IP addresses. Got it, right? Now you got the point. Why it is creating a common IP address and all. Why we require a load balancer and all. Okay. So that is the basic idea of Kubernetes. This one service object. Okay. So it is similar to the node port only, but it is used for the external connectivity of a pod or also network load balancing. Use it for network load balancing. Main point is it network load balancing means it will assign a common public IP for all the nodes combined together. So public will be able to access by using that common public IP. And from here, the load balancer ingress, the request will be diverted to the individual machines. That is the idea of service object. So we discussed about totally, you can understand that totally we have created. We discussed about different objects, right? We discussed about different objects, like we discussed about pod, we discussed about replication controller, replica set, deployment object, and we discussed about 3 service objects like cluster IP, node port, load balancer. Okay, we have a very good documentation in the Kubernetes, kubernetes.io. Please go and see. Okay, go and practice. In kubernetes.io, you can see that you can refer the YAML files. You don't need to go for anyone. Okay, kubernetes.io, it provides you the good documentation for the YAML files. You can refer there if you want to write YAML file. In that way, we can learn Kubernetes. Okay, this is about Kubernetes. If you have any doubts, please let me know. Among the discussed objects, we discussed totally 9 objects. Okay, these are the different types of objects we use in the Kubernetes. Any doubts you have in the Kubernetes? We'll go ahead. Otherwise, we will start a new tool called. We'll have a new. We'll go for discussing about a new tool called Ansible. Okay. Let me go to the new tool called Ansible. Let me start a new tool called Ansible. Right. Let me see. Let me give you some introduction part for Ansible. So Ansible, have we started the recording for this? Okay. Ansible is a configuration management tool. So we discussed about many tools so far. Git, we discussed about GitHub, Jenkins, Maven, Jenkins, Docker, Kubernetes. Now we are discussing about a tool called Ansible. It is also very, very important tool that is being used in the industry today as part of DevOps. So Ansible is a configuration management tool. So what is the meaning of configuration management? We need to understand. Many tools we discussed like Kubernetes is. What is Kubernetes? If someone asks you what is Kubernetes, what do you answer? It is a container orchestration tool. Docker is what? Containerization tool. Docker is a containerization tool. Kubernetes is container orchestration tool. Ansible is a configuration management tool. Ansible is configuration management tool. What is this configuration management? We'll understand. So configuration management is nothing but it is a process of configuring the remote servers. It is a process of configuring the remote servers from one point of control. What is configuration management? It is a process of configuring the remote servers. Process of configuring remote servers from one point of control. So what do you mean by configuring the remote servers from one point of control? Let's understand that also. Consider we are going to take some example here for understanding what is Ansible. I'm going to take some AWS cloud. Okay, consider you have an AWS cloud. Inside the AWS cloud, you have created some EC2 instances. You are going to maintain some 15 or 20 EC2 instances. Okay, 15 instances or 20 instances, whatever it is. I'm just going to take some example. So try to understand the example by using the same. I'm taking some example to make you understand what is Ansible and all. Consider all these are EC2 machines. These are the EC2 machines that are present in the AWS cloud. Okay, how many machines are there? You can give numbering also if you want. You can give numbering also. This is EC2 1. This is 1. This is 2. Okay, like that we have some different machines in the AWS cloud. 3. Okay, 4. There are many machines, but we are taking a small example. Okay, consider there are many machines in the AWS cloud, but we are going to take a small example to understand what is this Ansible and all. Consider we are having many machines in the AWS cloud, and I would like to install a software in all these systems. In this example, we have taken only 8 systems, but consider we have more than 8 systems. We have some 10 to 50, or we have 20 machines or 30 machines. But I need to install. I would like to install a particular software called. Jenkins. Okay. You just consider any other tool. It is not Jenkins only. I'm just taking an example. I would like to install Jenkins in all the machines. In all the machines, I would like to install Jenkins. Otherwise, I would like to install a tool called Git inside all the machines. So what I will do, if I want to install a particular software in all these machines, what I will do, team will be there. What actually the normal process is like, so each and every, we need to connect to each and every machine, right? First, I need to connect to the machine 1. First, I will connect with the machine 1. I'll install the software called Jenkins. I'll connect to the later, I'll connect to the machine 2. See, today actually the subscription of this Zoom is ended. So the meeting will be ended in 10 minutes. Once the meeting is ended, okay, we don't need to rejoin. We will join tomorrow. Okay, only 10 minutes. Okay, we'll be here only for 10 minutes. Once the meeting is ended, we'll join tomorrow. I think we have not seen for the subscription. Today we will pay for the subscription. From tomorrow onwards, we will join for 1 hour. Okay, today we will be closing it before 10 minutes itself. Okay. So we are going to connect suppose if I would like to install Jenkins in all the machines, what I will do, I will install Jenkins I will connect to the system 1, I'll install Jenkins. Similarly, I'll connect to the machine 2, I'll install Jenkins. I'll also connect to the machine 3, I'll install Jenkins. I'll connect to the machine 4. Okay, like that I need to connect to the individual machines, I need to install Jenkins. So if I want to do like this, it will take much amount of time. It will take days. It will take we cannot say that exactly it will be completed in particular period of time. It will take days, some days of time to get completed the task. Why? Because I need to connect with each and every individual machine. I need to go for installing it. It will take lots of time, lots of manpower. It takes lots of manpower, lots of time. Okay, so team should be there, team size should be there. So these are the drawbacks we're having when if I want to install a particular software in all the machines at a time. So there are some drawbacks. We cannot install. We need to connect each and every individual machine, and we need to do it. So by using Ansible, we can avoid these drawbacks. What I can do by using Ansible, what I will do is I will install Ansible tool in one machine. I will install Ansible tool in one machine. Consider I am going to install Ansible in one machine. Okay, so the machine in which or otherwise the machine where I am going to install that Ansible, that is called controller. I'm going to call that machine as controller. I'm not installing Ansible in all the machines. I'm not going to install Ansible in all the machines. I'm going to install Ansible only in one machine, and I'm going to call that machine as controller. That's it. So by sitting at one machine, by sitting at one point of contact, I can configure all the servers. I can configure all the servers at a time. I can configure all the servers. By sitting at one point of control, I can configure all the servers. I can manage all the servers. If I want to install Jenkins in all the servers, what I can do is I don't need to connect with each and every individual system. I don't need to connect with each and every individual system. First, what I will do, I will choose any one system among all the machines. If you have some 100 machines also, among the 100 machines, please select any one computer and name that machine as controller. Name that machine as controller machine. Okay, you can select any other. You can select any machine. It is not mandatory that you have to select the first machine as controller. Not like that. You can select any one machine from all the existing 100 machines. Name that machine as controller, and we will install a software called Ansible in that controller machine. We will install a software called Ansible in that machine. Once a tool called Ansible is installed, what can we do? We are going to install a software called Ansible inside it. Once we install Ansible, so by using this Ansible tool, we can configure all the servers at a time. We can configure all the servers at a time. I can update, or otherwise I can install Jenkins in all the machines at a time. Not by connecting to the individual machine single time. You don't need to connect with each and every individual machine individually, and you don't need to install that. Okay, you can install a tool called Ansible in the controller. Okay, you can install a tool called Ansible inside the controller machine. So you can connect to the Ansible and you can configure all the machines that I will show you how can we do it and all we'll see. Let's understand some more. So what is the advantages of what is the Ansible? Ansible is a configuration management. Now you understood, right? What is configuration management? If I want to install, configuration is nothing but if you want to install any software, or if you want to remove any software, or if you want to upgrade any software, we can do it by sitting at one point of contact, by sitting at one system, by connecting to the one system, we can do it. So what are the advantages you see? Configuration management is nothing but the process of configuring remote servers from one point of control. Process of configuring remote servers from one point of control. What are the advantages we're having? So applications that should be installed on server can be done very quickly from a single central location. We can sit, okay, we can sit on one location. The application that should be installed on the server can be done very quickly. If you want to install any softwares on all the servers, that can be done very quickly by sitting at a single centralized location. You can install that software in all the machines at a time. Next one, idempotent. What do you mean by idempotent? So these configuration management tools are used to bring the server to the particular state called desired state. So try to understand the meaning of idempotent. If the server is already in the desired state, the configuration management tool will not reconfigure the server. What is the meaning? So here we have many machines, right? We are going to install Jenkins in all the machines. But we don't know. In some machines, Jenkins is already installed. In this particular machine, Jenkins is already installed. But we are trying to, we don't know in which machine Jenkins is installed. We cannot check individually. So that's why we are going to configure in all the machines at a time. But unfortunately, in some machines, Jenkins is already installed. So in this machine, Jenkins is installed. In the last machine also, Jenkins is installed. Like that, in all the 100 machines, in some machines, Jenkins is already installed. So what can we do if Jenkins is already installed? If that particular software is already installed, Ansible will recognize that software. Ansible will not reconfigure that software once again. That is called idempotent. So the machines which are already installed with the Jenkins, the machines which are already installed with that particular software, those machines will not be reconfigured. If a server is already in the desired state only, what do you mean by desired state? What is your desired state? Your desired state is like you want to install Jenkins. If the server is already having Jenkins, configuration management tool will not reconfigure that server. Your Ansible, what is configuration management tool? Presently, we are using Ansible. We are going to discuss about Ansible. There are many configuration management tools. There are different configuration management tools. What are the different configuration management tools you see here? Ansible is one tool. Chef is one tool. Puppet is another tool. Salt is another tool. So these are the most widely used configuration management tools in the industry today. Among all of them, Ansible is the popular and widely used tool today. Chef is being used, Puppet is being used, Salt is also being used. Everything is similar. All the tools are similar. But what is the most popular one, which is used in the DevOps? Ansible is the tool that is being used in the DevOps widely today. Okay, very popular tool. You understood what is the meaning of idempotent. If the server is already in the desired state, if you would like to install Jenkins, if the server is already having Jenkins, no, configuration management tool will not reconfigure the server. Configuration management tool will not install Jenkins once again. Note, configuration management tool cannot be used for installing OS from the scratch. You may think like this. Suppose by using Ansible, even we can start installing OS from the scratch. No. This Ansible called configuration, this Ansible, which is called as configuration management tool, this is not used for installing OS from the scratch. It is not used for installing OS from the scratch. It is used for managing the applications. This will be used for managing applications on top of OS. This will be used for managing the applications on top of OS. These tools cannot be used for installing OS from the scratch. These tools cannot be used for installing OS from the scratch. These are used for managing the applications from the top used for managing applications on top of the OS. These are the tools that are being used in the industry today. But anyhow, Ansible is the most widely used tool in the industry. So Ansible is an open source tool. All DevOps tools are open source tools only. So once it is disconnected, we will connect tomorrow. Okay. I think we don't have time. Once it is disconnected, we'll connect tomorrow. So the main machine in which the Ansible is installed, it is called as controller. Main machine in which the Ansible is installed, it is called as controller. And the remote servers, wherever we are going to configure